Hi everyone, so this is Amit Srivastav and today we are going to talk about the various components and services of Microsoft Azure Cloud Platform. So we are going to see an overview of various offerings from Azure Cloud um, in various perspectives such as compute services, storage service, database services, or some security services. So let's begin. So the first one that we are going to talk about are compute services. So compute services are offered by Azure in two forms. One is infrastructure as a service, which is IaaS, and also platform as a service, which is PaaS. So the difference between the two is that when users take up infrastructure as a service, then they can create the resources in Azure platform, but it is the responsibility of the users to maintain those resources, to do any updates or security patches. When users go for platform as a service, then besides taking the physical resources, Azure also takes care of all the management of the resources, the life cycle of the resources, any security patches, updates, and it also provides the features to support the end application of the user. So in short, user has to just take care of his applications. Rest all in infrastructure, its configuration, maintenance, and connectivities are taken care by Azure. So that is platform as a service. So first compute service we are going to talk about are virtual machines or VMs. So these are offered as infrastructure as a service by Azure, wherein users can create physical machines or servers to run their applications. And these VMs can be of various OS images or of various computational power, but user needs to take care of all the maintenance, that is operating system updates, any security patches, etc. The second compute service is like virtual network. So it is also a infrastructure as a service offering wherein users can create the virtual network for their virtual machines. They can create the subnets. They can create the virtual network interface cards, also called as NICs, to connect to the virtual network. User can get one or more public IP addresses. They can create internal and public DNS names, and they can also create the network security groups and rules which secure and control the flow of network traffic. The third one is app services. So basically, app services is a platform as a service offering by Azure, which means using it, users can host their applications in a fully managed application platform, and it provides a collection of hosting and orchestrating services also, and features to secure the application using Azure Active Directory, use custom domains, and also it users can choose a app service plan for their um, applications or application services, uh, and in that app service plan user can have one or more VMs to run, and users also get the feature of continuous deployment and app service certificates, and also the Azure deployment slots. So these are all the offerings from Azure App Services. Now, under the Azure App Services, if I talk about the concrete of offerings, then there are few. One is Azure Web App Services. So what it does, it is used to host our web applications or any APIs which can be a REST web service. So basically, in short, Azure Web Apps are used to host any HTTP driven application. Next is Azure Web Apps for containers. So using that, we can easily deploy and run containerized web applications at scale. We can run Docker containers on Linux and Windows platform. And the thing to note here is that our applications are hosted using a predefined application stack which is based on the Docker container. So next is Azure Container Instances. So this is again a platform as a service offering, and it lets us create and run containers. Thing to note here is that there is no upfront network resources which are to be created or configured. These are taken care of by Azure itself. Next is Azure Kubernetes Service. So Azure Kubernetes Service, or AKS, is an enterprise-grade managed Kubernetes service, and it is Azure which handles tasks such as health monitoring, maintenance, availability. Developers need to just focus on the application that they want to deploy in the Kubernetes or Azure Kubernetes cluster. Azure Kubernetes Cluster also provides the features of multi-layer security across operating systems, compute resources. It provides data networking, managed identities with Azure Active Directory. Then it also provides secret integration with Azure Key Vault and some of the policy management services. Next is Azure Container Registry. So it is nothing but a kind of registry for containers maintained by Azure. We can use it to store our container images. It is a private registry for your container images, and with all these security in place and also the role-based access control mechanism existing for authorization. Then there is Azure Red Hat OpenShift. So as we know, Red Hat OpenShift is an enterprise Kubernetes container platform. So when that runs in Azure platform, so we call it Azure Red Hat OpenShift. It on top of all the offerings by Kubernetes, what we get extra in Azure Red Hat OpenShift is that it provides like few of the important features and services, such as the authentication part, or maybe centralized logging, or some CI/CD tools. So all these things we get when we use in Azure Red Hat, which we don't get when we just use the Kubernetes. Next one is Azure Functions. So basically, Azure Functions are used. Basically, what should I say? Is it's used to create a solution, coding solution for a smaller pieces of tasks. We just write some few lines of code in any of our favorite programming languages to solve a task or to do a task, and that is it. We don't have to build a full application, a running application, or we do not need to configure or build an infrastructure to run that logical code. All that is taken care by Azure. These Azure functions can be triggered by an HTTP request or any other event generated by other Azure service, and it can also run based on a schedule. So one good example of Azure function is, suppose I need to store the metadata of any of the object, which can be image, video file, which gets stored or uploaded to my Azure storage. So for that, what I need to do is I just need to create a Azure function, and I just need to write only those lines of code which is used to extract the metadata from the objects. So that is it, and we can integrate those Azure functions um, with the Azure storage service, so that whenever there is any upload in the Azure storage service, my Azure function will get automatically triggered. Then these Azure functions runs under a consumption hosting plan, which is also very good, because with this, developers need to pay only for the time spent while running the Azure function. So if I deploy my Azure function and it is not getting used, I don't have to pay anything. Only when my Azure function will be used, then for that time duration only, I have to pay. I mean, how much is like for what time my Azure functions were used. Based on that, I have to pay. Next is Azure Logic Apps. So basically, these are used for orchestration of business logic by automating a business process, or maybe integrating with other Azure applications or services. So it has connectors which can integrate to APIs. I mean, which can connect to Azure SQL database or any other Azure services, and based on that, we can automate the business workflow. So to explain it in simpler words, suppose we have a requirement that new orders are gonna come over email, and we need to see the content of the email and then check whether those goods are existing in inventory. Based on that, we have to revert the end users on email. So all this can be automated using Azure Logic Apps. So it can integrate to the email system. It can integrate to Azure storage service to find the inventory status. So all these things can be done and automated using Azure Logic Apps. Next is the Azure Spring Cloud. So using Azure Spring Cloud, we can deploy Spring Boot microservices applications to Azure without any code change or extra code to make it compatible with Azure. We can do the deployment using the jar or even the code, and it has all the features of Spring Cloud, that is service discovery feature, configuration management, distributed tracing, and all. So, and all these are offered as a platform as a service by Azure. Next is let's shift our focus to Azure Storage Service. So in that, let's first talk about blob storage. Before that, I would like to call out that all the Azure the data that we store in any of the Azure storage services is geo redundant, which means I can save a replica of that data on different physical servers in the same data center, or maybe in different data centers in a zone, or maybe different zones in a Azure region and also in different Azure regions. And whatever data we save, it is encrypted at runtime. So yeah, let's move to the Azure Blob Storage. So basically, Azure Blob Storage is used to store large unstructured data, which can be blocks of data like a video or a image, audio file, text file, and also the virtual hard drive files for VMs. Then blob storage is further categorized into three categories, or basically three types of blobs that we want to store. So the first one is page blob. So page blobs are used when there is a requirement of random read and write operations, maybe for storing a virtual hard drive. And then block blobs. Block blobs are used for uploading large amount of data, which can be large video files, etc. Then append blobs are optimized for append operations, which can be any operational logs, etc. After blobs, we have table storage, which is a kind of fast NoSQL key value storage. So whenever we have to store any key value unstructured data, then we can go ahead with table storage. Next is the queue storage. It serves as a queue and stores small messages, and it also serves the purpose to connect the two applications using a messaging layer or a queue in between. Third is a file storage, which is basically used as a drive from where we can share files. And the thing to note is that it uses a server message block or SMB protocol, and it can be accessed from either cloud or from on-premises systems when there is a path to Azure available. Because as I said, it's used server message block protocol, and that's why these SMB shares are blocked from internet. Next one is disk storage. So it is more or less like a file storage, but it is meant for high I/O performance. One use case can be that it can be used as a drive in a VM, which requires high performance to run SQL Server. Then Azure Data Lake Storage. Basically, it is a storage which very high, huge capacity to store any unstructured data of various formats, and this data can be later used for any analytics or transformation. So then this Azure Data Lake Storage can be used. So apart from Azure Data Lake Storage, which is a platform as a service offering by Azure, the rest five are the infrastructure as a service offering by Azure. Next is are the database services. Right. So the first one we want to talk about is Azure SQL database. Right. So this Azure SQL database is basically like relational our MS SQL server, which we use on premises data centers. So it's like that only. It is a relational database system, but Azure SQL database is fully managed cloud service, which is performant, scalable. It gets automatically backed up. There is a SLA of 99.99 uptime, and the data is again geo-replicated, and there is features of dynamic data masking. Then it has the feature of transparent data encryption, which means that data is protected when it is at rest from unauthorized offline access. It also supports always encrypted policy, that is, you can store and query encrypted data from within the database, protect sensitive data by encrypting it on the client side. The next one is Azure Database Managed Instances. So we go for it when we don't find any specific feature which is required and it is not there in Azure SQL database. So suppose when on premises we use a PostgreSQL database and it has some feature which is very important and required, then I can go ahead with the Azure database managed instance for PostgreSQL. So likewise, this Azure database managed instances are available for MySQL, PostgreSQL, MariaDB, to my knowledge. Then comes Azure Cosmos DB. So basically, Azure Cosmos DB is a very powerful, fast and flexible NoSQL database which is built for cloud native applications. It provides guaranteed availability and speed at any scale with the SLA of 99.999%. And in terms of latency, it provides less than 10 milliseconds latency on reads and writes. It has open APIs for MongoDB, Cassandra, Graph Data, and also a PostgreSQL API with SDKs for .NET, Java, Node.js, and Python. It also has the serverless and auto-scale options. The data is geo-replicated. It automatically indexes the data, and it also provides all the 5 data consistency levels, that is strongly consistent, bounded stillness, session consistency, consistent prefix, and then at last eventual consistency. Now let's talk about the messaging services. So in our modern world of microservices, we want our microservices to be decoupled from each other, and for that we need some messaging layer in between. So let's talk about those. What are the offerings from Microsoft with respect to that? So Microsoft gives us the Azure Service Bus that is used for decoupling the microservices via persistent messaging layer, and this actually comes in two formats. One is Azure Service Bus Queue and Azure Service Bus Topics. So basically we use Azure Service Bus Queue, and there is a requirement that I have multiple publisher applications which are going to write the data to the queue, but there will be one subscribe pair application which will process the data, or there can be multiple subscriber application, but that data which is published will only get processed by or received by a single subscriber application. Then we go for Azure Service Bus Queue. Next is Azure Service Bus Topic. We use it when there is a requirement that I need to have multiple subscribers or publishers publishing the data on a topic, and there can be multiple subscribers and each of the subscriber needs that data. Then we go for Azure Service Bus Topic. Next is Azure Event Hub. So basically it is used to capture massive amount of data to analyze and also for transformation. So when I say massive amount of data, by that I mean millions of messages per second. The use case can be the signals coming from the IoT devices, which are huge in number, maybe millions per second, and all have to be captured and stored. Then we go for Azure Event Hub. And thing to note here is that it retains the messages for up to 7 days, but it can also indefinitely store it by writing messages to a data store using Event Hub's capture feature. and we can also query the data from within the Azure Event Hub. Then it is Azure Event Grid. It is again a fully managed PubSub service that can be integrated with many Azure services or even custom publishers and subscribers. So when I say it is a PubSub service, then if you remember, I talked about Azure Service Bus topic. That also acts like a PubSub. Then what is the difference? The difference is that in Azure Service Bus topic, it is a responsibility of the subscribers to pull or pull the messages. So it works on a pull model, wherein subscriber pull the messages from the queue. Whereas in Azure Event Grid, it is the responsibility of the grid to publish the message to the subscribers in real time as soon as the message arrives in the event grid. So, which means lower latency and kind of it can be used for in reactive applications. So now let's jump our focus to the security services which are provided by Azure, right? So the first thing that we are going to talk about is Azure Active Directory. So basically, it is used for managing the identities, similar to what we have Active Directory on our on premises. So in Azure, it is Azure Active Directory. It manages the identities and and it helps in authentication, and there are various ways which we can use it. Then Azure Key Vault. So basically Azure Key Vault is used to securely store and say manage certificates, keys, and other secrets which can be passwords or something. And so when we use Azure Key Vault and say as store any just for an example our database password in the Azure Key Vault, then we don't need to anywhere write or configure that database password in any of the configuration files. Whenever there is an application which needs to connect to the database, then that application will register itself as a service principal in the Azure Active Directory first, and then it is going to get a token from the Azure Active Directory. That token the application will present to the Azure Key Vault. Azure Key Vault will validate that token whether that application has the required access to that password, and if yes, then Azure Key Vault is going to return the password of the database, and using that password the application can connect to the database. Then we have Azure Azure Web Application Firewall. Basically, it is again a managed cloud native service that provides powerful protection for web applications. It protects from malicious attacks, web vulnerabilities such as SQL injection and cross-site scripting. And whenever it detects any malicious attacks, then it blocks that from reaching the web application. So it's a very powerful protection layer for any web application. The next one is Azure Front Door. So Azure Front Door is a global scalable and entry point for any web application. It provides load balancing features and it helps in reducing the latency, increased throughput, and it also provides a modern content delivery network. But how does this help in security is what I'm going to say next. So it protects against the network application layer attacks at the edge server with web application. So when I say uh, network application clear attacks, then you can think of it. It protects against DDoS. So that is one of the example. Then let's shift our focus to some API services. So we all use APIs in our modern world of microservices. So Azure provides the Azure API management, which is used to create API gateways for existing backend services. It provides security, prevents like OWASP attacks. It can protect against DDoS, and it basically secures the backend microservices. We can also implement the JWT token authentication in the API gateways itself. So the request will first get authenticated and then it is going to reach the backend services. And once we build a API gateway, then it is our API gateways which is exposed to the outside world. Rest all the other backend microservices are sitting behind the API gateway, so they are in a way more secure. Then we have Azure Application Gateway. So what is that? So basically, it offers us the layer 7 load balancing, and it has layer 7 routing capabilities. It uses round robin distribution of incoming traffic. It also has cookie feature for cookie based session affinity, your URL based routing, and with all this, we can say that it has the ability to host multiple. We get the ability actually to host multiple web apps APIs behind a single application gateway. Then let's touch base upon some load balancing and latency services. So we have Azure Load Balancer, we have Azure Traffic Manager. So how Azure Traffic Manager differs from Load Balancer is that Azure Traffic Managers works at the level of DNS. So whenever any web request is going to come, so it is going to route it to a web server which is closest to the source of request. So thereby reduces the latency. Then we have Azure CDN, which can be used, which is a content delivery network. So all the static files or cache data can be saved in the CDN, and whenever any request is going to come for that data, so it can be directly pulled from the CDN without reaching the actual server. Therefore, it reduces the latency. In terms of caching services, also Azure provides, say, Azure Redis cache. It is a kind of Redis cache which is fully managed by Azure. So the user has to just take care of the data which is like be concerned about the data which is saved to the cache or retrieval of the data from the cache. This the infrastructure and Redis cache is all managed by Azure. So that's all, friends. I think that's all I wanted to cover. It's a kind of overview of various Azure services which Azure Cloud provides, which we can use. These are quite useful. And in the subsequent kind of videos, I'm going to deep dive, deep dive into all these services one by one, wherein I'll show you how to create those services, whether from Azure portal or Azure CLI or PowerShell, and how to integrate them with our applications. So stay tuned. Thanks a lot.